Okay, thank you, Chuck. Appreciate it. All right, hello out there to everyone in the Great Lakes Bentley user group. Thanks for attending and welcome to the OpenPlant presentation.
Let me just say though, if you have any questions during the presentation, go ahead and put them in the Q&A box, and then we'll go over them at the end of the webinar. Go ahead, Ed.
Yeah, great, thank you. Okay, so a quick agenda. This presentation will run about 45 minutes and we'll leave about 10-15 minutes at the end for questions, and I can also stay past the top of the hour, however long it takes to answer all your questions. So just a quick introduction of myself. My name is Ed Kirkoska, and I'm a senior application engineer here at Bentley Systems. I've worked with Bentley Systems for about 13 years, dealing with all the various plant design products from 2D process design up into 3D detailed design. And my roles span everything from sales to training and some consulting and support to our plant users across North America in various industries. I did go by it quick there, so just want to say, so today we're going to take a quick look at what OpenPlant is for those of you who you've never heard of OpenPlant and you're curious what it is. And we're also going to talk about a new solution out from Bentley called PlantSight and how that works with OpenPlant. And we'll get into some of the product overviews. And as Chuck said, we'll handle some questions at the end. So here you can see the Bentley project playlist showing what products you can use for the various industries. So this shows the amount of software that Bentley develops and shows our commitment to advancing infrastructure. We're just going to focus today on the OpenPlant products. And as you can see, OpenPlant can be used across many different industries, from utilities to power to process to water and wastewater design, minings, and other. Obviously, if it has piping in it, you can use OpenPlant for it. So what is OpenPlant? It's basically a set of tools used for 2D and 3D design. And it's built on an ISO 15926 open standard. And it's designed for interoperability with other design systems using what's called iModel technology. We'll talk about that in a little bit. It has integration with our document management, engineering, content management software called ProjectWise, and it's scalable from small projects up to mega-sized projects. And I wanted to talk a little bit about PlantSight. So PlantSight is a variety of various cloud-hosted services called iTwin services. And they're used for creating and maintaining what we call digital twin. Some of you may have heard the term digital twin, and it's used for creating and maintaining this digital twin out in the cloud. Those various services help maintain and keep your digital twin up to date. And today we're going to see OpenPlant being used with PlantSight to keep this digital twin in the cloud up to date. And we're only looking at a small portion of PlantSight today used for the design side, design and build aspect of updating that digital twin. But as you can see, there's other aspects of PlantSight to be used throughout operation and maintenance of your project. So the various OpenPlant products that we're going to talk about are OpenPlant PID for the 2D PID design, OpenPlant Modeler for the 3D design, support engineering for pipe support design, Isometrics Manager for generating isometrics, Orthographics Manager for generating your 2D orthos, and Project Administrator, which we're not really going to see Project Administrator today. That's strictly a tool for administering your project, doing all the setup type stuff. So what is OpenPlant PID? So OpenPlant PID is basically a set of tools for 2D PID creation. It's easy to learn and use the tools. It's fit for purpose, which means it only contains the tools you need to produce your PIDs. It's ISO 15926 compliant, and it integrates in with our conceptual design feed software, instrumentation, electrical applications, and 3D specifications. So what you'll see, the scenario that you're going to see in this presentation will be myself and a colleague of mine, Ari, who is working on the same project as I'm working on, and I'm going to place some components in a PID, and then he'll connect into my PID and connect onto that process line from my PID and continue drafting. While we both sync our components into PlantSight, and we can use that data to access it from the 3D model. So as you can see, OpenPlant PID has some predefined menus for placement of all these intelligent components. We're going to start by placing some standard components. I'm going to place a pump here, simple pump, and give it some property information, or we can fill in a dialog and give it a name or a size or material or any other properties. And next we're going to pick a process line, a major process line, and give it a tag and choose its unit or service or area, whatever properties you define for that process line. And we can then set the pipeline size of it. So this is where we would choose a size and spec, whatever piping spec we're going to use, whatever size we're going to use. And then you can start placing some inline components, like I'll just place a simple gate valve on here. And again, give any tagging, naming information, fill in any other properties about that particular gate valve. And you can right click and review any of the properties on these components after they've been placed. And you can change data in this property dialog box. Next, we're going to place a intelligent page connector. So if I'm running a process line off of a drawing, I'm going to connect to this particular process line. And these actually will link the lines from one drawing to the other. And now I'm going to synchronize this data up into this cloud repository called PlantSight that I talked about. So this is storing all the data that I have added into this PID up into PlantSight. And some other advantages to using an intelligent PID, one of the things are we can generate reports, for example, line list reports, valve list reports, equipment list reports, instrument list reports. And these can all be generated automatically just by opening up the reports dialog and right-clicking on it. And you can either generate an external report or you can place it as a table directly on your PID. For example, I'm placing this equipment list. I'll place another valve list report. So instead of manually having to count up valves and instruments and equipment and process lines, you can generate these automated reports from having an intelligent PID. If something gets updated in the PID, if I add a component, for example, if I go in here and place another pump, those reports, they don't update on the fly, but they will update when you click on them. So if I place this pump and give it another value or name, fill in whatever properties I want to fill in, and choose OK. And now it's placed, it will be placing the pump in there. And I can key in whatever tag I want. And now that that's been placed on the PID, I can click on that report, which is we'll call the table. And if anything changes from the PID, you can simply choose the icon up above in the ribbon menu there to refresh the table. And it'll refresh and add in anything that's been added into this PID since the last report was generated. So let's place a couple other components and just look a little more in detail. Let's place another valve just so I can show you some of these more properties a little closer. So I'll insert a gate valve into this pipeline, and all these various properties can be populated now or when you know these particular items that can be filled in. You can also create custom properties if you have your own client-specific properties, for this particular project. You can add them in there and fill in those properties for that particular component. You can also right-click and annotate. So very quickly, any annotation that's been needs inserted on your drawing, if that tag or name changes from HV001 to something else, it'll change on the fly. In this example now, Ari has switched over into his PNID, and he can browse my PNID and view all the connecting labels. So in this case, he picked the connecting label that was on my PNID that I finished off with, and it will now be smart enough to take on all the intelligence from that process line. So the size, the spec, the line number, any property information that's been updated in that line automatically gets placed on this PNID. So this workflow is going to show, I placed my information on my PNID. Ari's now drafting up his information on his PNID. He's going to place another process line here and tee into the existing process line that I originally placed and place some inline components. The purpose of this is to show how multiple users can synchronize their data, their process data, into the PlantSight environment. So this is to simulate two separate users working on two separate PNIDs at the same time, filling in all the intelligent property information that needs inserted or filled out for that particular PNID, and then synchronizing up into PlantSight. So at this point, he's just doing some final annotation. He can grab annotation commands and just hover over a process line, and it will automatically annotate it based on some predefined annotation settings. And he's going to synchronize into PlantSight. So at this point, it compares what's out in PlantSight to what is in his particular PNID, and it will bring up a differencing dialog showing any changes that have been made. So anything that's been inserted or deleted or modified would show you in that dialog, and we'll just simply update it. So drawing has been successfully synchronized with PlantSight. So next, he's going to enter the PlantSight portal. And a user can enter into this particular PlantSight project. We were calling this one Work From Home. And we're going to visualize the changes that we made in the 2D PNID. So in this case, he's browsing out to the PNID that I was working on, and you can zoom into the area where the PNID was at and see all the changes that I made on my particular PNID as I'm working on it, and review any property data. You can right click and review any OpenPlant properties. And now he's switching over into his tower PNID and reviewing the changes that he made on his PNID. So think of this as someone out just using a regular web browser can log into the project and look at any of these design aspects of the PNID. Next, we're going to take a look at the query section. This actually queries all the detailed data within the PNID. So all the equipment information or pipeline information or valve information. And it's a table view that a user can not only view, in this case, we're viewing the equipment list and all the equipment from all the multiple PNIDs in this project, but you can also populate, you can import and export to Excel. You can change data directly in here. So in this case, we're editing the table directly, and he's going to go in and edit a particular column for manufacturer and change it from KKB to a Gould pump, for example. And you can change anything else in here, paint code, material, any other properties in here that you want to populate. So the goal of this is to show you that outside of the PNID environment, someone can browse out through this PlantSight portal, change items, in this case, manufacturer, material, and paint code, and save those. And at this point, a user that is in the PNID product can then open the be back in the PNID environment. So now we've switched back into my PNID. And I'm going to right click on this particular pump, view its properties, and you can see these properties for Material and paint code and manufacturer are still the original ones. KKB, and nothing's filled out for paint code and material. So we want to bring those changes that another user made out in PlantSight and synchronize them from PlantSight up into my drawing. This example, now we're synchronizing, it's comparing, and it's looking at those changes, and it sees that there have been some value changes for these properties: material, paint code, and manufacturer. Those have been updated, the old value, the new value, and you choose update. And now I can right click on the pump and you will see the new properties updating. So you'll see those values change to gold, PA1, and steel for material. So my last step is I'm gonna synchronize all this updated information from the PID back up into PlantSight, and we're gonna use this data going through into our 3D environment next. So that does a comparison to PlantSight and synchronizes over into PlantSight, and then we're updated and ready to go into our 3D environment. So next, we want to take a look at OpenPlant Modeler. What is OpenPlant Modeler? It's basically the 3D piping design system. It has predefined pipe specs and vendor catalogs. Out of the box, you can model various piping, obviously. You can model equipment. There's even modules in there for modeling steel, HVAC, cable trays, and pipe supports. You can generate your intelligent isometrics directly for fabrication from the 3D model. You can generate your bills of material, your plans and section drawings. There's 2D to 3D integration, which you're going to see, bringing process design up into 3D detailed design. There's point cloud capability, reality mesh capability as built-in clash detection, and you can produce DWGs, DGNs, and other formats. Isometrics Manager, which you're also going to see, this is an ISO tool that automatically takes the 3D piping systems and generates your fabrication isometrics from it, and you can customize those and make them look and feel the way you want. So again, just like the PID scenario, what we're going to see now from the 3D modeling side is OpenPlant Modeler interfacing with PlantSight. We're going to see modeling of equipment and piping components, checking components in and out from PlantSight, bill of material reporting, isometric creation, and orthographic drawing generation. So next we're going to enter the OpenPlant Modeler environment, and we're going to start by choosing the Explorer. In this scenario, we're starting with an empty file. There's nothing in this file. We're going to browse out to Explorer, and we're going to browse into our PlantSight environment, and we're going to reference out the areas that we want to start working on. I've created some predefined volumes here. We can reference out by volume. So we're referencing out these volumes. This is read-only at this point. These are just like a reference file or XREF that can't be changed. It's only being used for reference. So in this scenario, we're mimicking a couple designers, myself working in my environment, Ari working in his environment. And I'm starting out with this modeling data that I have referenced out, and I will zoom in and rotate into an area here. And I'm going to start by launching the 2D to 3D Consistency Manager. And what the Consistency Manager does is it views all the components in PID and 3D, and it'll highlight any in red that aren't in 3D versus 2D. So in this case, this pump is not in my 3D model yet, showing up red. I'm going to right click on it, insert it into my drawing. It takes on all the unit and service and area and tagging from the PID. And we also can have predefined templates. That obviously came in as an out-of-the-box size, and now I'm browsing out to a template, which will redraw it in the matching to the pump next to it. So it's just some templates I had set up. Next, we're going to insert the nozzle. So again, I can have predefined templates to insert nozzles at different locations and dimensional properties. But I can also browse out to PlantSight, so PlantSight knows that I'm on PMP 401 and it knows there's this unused nozzle out there from the PID, and I can insert that from 2D to 3D. And you'll see these icons that show if it's been placed in 3D versus 2D. So next we'll go down to the process line that I created in 2D, and we simply right click on it and choose create pipeline. That creates the pipeline up in our standard preferences with all of our spec and size and line number. And we'll also browse down through and look at what valves are on that particular line. So first we'll model some piping in. The piping tool has all the automated routines for auto inserting flanges and elbows at intersections and T's and whatnot as you're modeling. And next I'll right click on the gate valve that I want to insert from the PID. So in this case, that's the gate valve. It'll take on the tag HV401A, orient the hand wheel. So at this point, I want to share this data with other users. In this example, I'm going to share it with Ari. So we're going to update PlantSight, which doesn't, it checks in all the changes, but keeps the modeling part checked out to me. So update just updates PlantSight with what I'm working on, but I still have this checked out to me, so I'm working on it. Now we've switched over into Ari's model, and he wants to see what I have added in. So he's going to browse out the PlantSight and refresh his references, which will now show the pump and the piping run and the gate valve that I worked on in his working environment now. And if he browses PlantSight Explorer, he can see that that particular line, 401, if he browses over into PlantSight and browses to 401, he can look at the status of that line and see that he can't check it out. It's showing up that Ed Kirkoska has that locked. So in this example, I'm switching back to my model now, and I'm going to check in all my changes. So I'm checking everything in from my modeling environment back into PlantSight, so it's going to completely disappear from my model. So everything that has been changed, if anything's been changed since the last time I synced, it's going to check it all in to PlantSight. And now Ari will be able to check that data out to continue working on it, because he needs to tee into the line I modeled. If you remember on his PID, he teed into the process line that I drew. So he's mimicking now, checking out the line that I worked on in my modeling environment. And he's going to clear the references here just to show you that everything was referenced out into his model. And the only thing he actually has physically checked out to work on is that process line that I was working on. So now he'll start reference out the actual pump, so you can at least see the pump that I was attached to. And now he'll start modeling his changes that he made in the PID. So he's going to tee into this particular line, go into his piping preferences, get into a view that he can see clearly here, place a T, and then start modeling his changes from the PID. So once he finished his modeling the line now in here, he's going to browse out and grab that line from the PID that he created, which was 405. It's in that tower PID. Save it, and then he can continue modeling with 405 spec defined and size defined from whatever came over from the PID. So you're seeing another way you can browse out. So I used a 2D to 3D consistency manager to browse out to the components. You can also place them first like he's placing. So he's placing a gate valve where I used the right-click insert, he's going to insert the valve and browse out to the PlantSight environment and see the available tag and insert that gate valve. So he's finished his design based on the changes that he made in his PNID. He's going to finalize his session here by checking in all the components. And this will do the comparison out the PlantSight, show any changes that have been made, and check everything back into PlantSight. So the last step here, we're switched back into my environment, and I'm just going to reference out all of the changes. So I'm going to reference the entire volume out again, volume 1, which shows all the changes that Ari and myself have made to this point. So that's a little bit showing that workflow with multiple users working together. Some of the other advantages of a 3D intelligent piping system is I can get bills of material reports. So if I hover over these lines and grab a couple line numbers from the pop-up display there, I can generate my bill of material reports based on those line numbers. These are all out of the box, but let's say I want to generate a BOM by line number. Simply right-click, run the report, and you'll see I'll get an automated bill of material report by line number with all the components it takes for that particular line number. And you can see our 401 line that we modeled and 405 line down here at the bottom that we modeled. 102, whichever one he modeled there. These can be exported out to different formats, so you can save them to Word, Excel, PDF, pretty much any format you need to go to. And of course, you can print these out. So the next, one of the next valuable deliverables from the 3D model is an isometric. Within the utility, there's a tool called Manage Pipelines or Pipeline Manager. And here you can browse all your line numbers in your model, in this case 401. If you have many pipelines and you don't feel like viewing through a long list, you can key in a filter. So this will filter out all the lines with 40 or 401 in them. And to generate an ISO, I simply click on Auto Generate ISO Sheet and then Auto Generate the ISO. So what that Auto Generate ISO Sheet does is you can define what piping components go on each isometric. So in this case, Auto Generate just puts them all on one isometric. And once that ISO generates, you can right click on it, show isometric, and you can view the ISO. Again, this is 100% configurable, how you want things to show on the isometric, weights, colors, levels, things like that, and how you want the bill of material to show. Just go forward a couple minutes here. Just we can generate multiple ISOs just by selecting multiple, checking on multiple isometric boxes here. Generate the ISO, and it'll generate multiple isometrics, and then we can view those isometrics. So the other deliverable we can get is orthographic drawing. So what's called dynamic views in OpenPlant Modeler. It's inherited right from the MicroStation world, the MicroStation engine. So I can use the section tool. I can take a section, create a drawing that is going to be created from this 3D model. And it automatically generates the section view with that plan view attached with your customer border attached. And now you can go in and do all your annotation. You know, in this case, some dimensioning between two beams. You can also annotate any of the properties from the intelligent components. Since all of these OpenPlant piping components have properties to them, I can use the place text command and choose element properties, and I can just simply browse the particular component that I want to annotate and choose whatever value I want to annotate from it. So in this case, an actual line number I'm going to annotate. Text sizes and fonts and all that type of information can be controlled by a text style within your drawing. So control how you want that text to show. And again, I'll jump forward here. I'm just placing a couple more annotations for a hand valve, whatever tag for that valve, and whatever tag for that particular piece of equipment. So the other thing I want to show is how easily we can create these section views from this particular plan view. So in this case, I've created a plan view, but now I want to create a section view looking from the side. Let me just. So we use this section callout tool, and we're going to view a section from the side. We're going to choose 2 points and then how far in this pipe rack we want to go. And this is what we call a dynamic view. We'll place this on this particular sheet that I'm on. And any scale factors we need, I'm going to turn dynamic on, so it dynamically updates as we change our clipping planes. And it inserts it in the drawing. At this point, it's just a regular reference, so I can move that reference to where I need it in my drawing. And a dynamic part is, at this point, I can grab that section callout and I can drag those clipping planes, those little handles there, and you'll see as I drag that section callout, you'll notice that section view updating over on the right-hand side. So this goes to show you some of the flexibility when it comes to creating these orthographic 2D plan and section views. You can very easily create these section views from OpenPlant and have them dynamically update if anything changes on the model. Of course, they'll change in the actual 2D drawing. So some more information on PlantSight. You saw a little bit with how OpenPlant works with PlantSight from the PID side to the 3D side. The products listed in here also work with PlantSight. We also offer what's called bridges to upload design data from other applications into PlantSight, like AutoPlant, SmartPlant 3D, E3D, and PDMS. Products like Plant Design Series and our Plant Space Design Series and PDS, those get converted up into OpenPlant or can get converted into OpenPlant and then work bidirectionally with PlantSight at that point. And then tools like Isometrics Manager and Orthographics Manager can also generate drawings directly from PlantSight. So with this PlantSight, what we'll see here is accessing the PlantSight portal, which we already saw a little bit from the PID side, but we're going to see some on the 3D side now, zooming to components, reviewing properties, 2D to 3D visualization, and version comparison. So now that myself and Ari have checked all our data up in the PlantSight, now others can just log in through a web browser into the PlantSight project. In this example, another one of our colleagues, Michelle, is acting as a project manager, and she's logging into PlantSight, and she's going to visualize the 3D information now in this project. So this is to mimic someone going in through PlantSight and being able to review any of the design data. So once you're in here, you can rotate and navigate around your actual model. You can do your walkthroughs or whatnot in your actual 3D model. And you also can choose any property data. So you can turn levels on and off. That's what we're doing here, turning some levels off. But if I click on this particular pump, I can view the pump data by reviewing the properties. So this is all the data that came from the PID and 3D model, reviewing this directly in PlantSight. And we can also do a 2D to 3D visualization. So I can click on the pump in the 3D model and it will bring up and browse to and highlight the pump in the PID. So in this example, it highlighted the pump in that actual PID. If I click on a different pump, you'll see it highlights that pump in the 3D model. If I click on the vessel in that PID, it'll view that vessel over in the 3D model. So that's very nice to be able to navigate around clicking on components in 2D or 3D and being able to see them in 2D and 3D. One of the other options we have in here is to do a version comparison. So as we check that information into PlantSight, you can create, call them snapshots or snapshots in time of the eye model at a certain point in time. This way we can do version comparison between those different eye model versions. So here we're entering this eye model, and we're going to view the changes between this original model that was checked in the state that you see it and the version that we just checked in. So we're going to compare our version 4 to our version 1. And you can turn on down in the comparison legend, you can turn on and filter just by items added, but you can look at if anything's been modified or removed or unchanged by different color coding. In this case, we're turning everything off and we're only looking at the information that has changed. So you can see the item information that myself and Ari have modeled in 3D. So next, what we'll take a look at is OpenPlant Support Engineering, another OpenPlant product. So this can rapidly and accurately place various pipe supports from different vendor catalogs. You see different catalog providers: Anvil, Carpenter, Patterson, Bergen, and Piping Technology, Standard Supports, and others. So there's over 15,000 supports in here that you can place in your 3D model. And OpenPlant Support Engineering gives you the ability to automatically generate drawings from those models and generate bills of materials and reports. So what we'll see in this little video is placing a couple various supports. We're going to place a U-bolt and another spring hanger, and we'll create some detailed drawings from them and generate some reports. So this enters into the 3D model that we have referenced into OpenPlant Support Engineering, and as you can see, you can pick from a variety of various ribbon menus and get various attachments like clamps and shoes and U-bolts and others. There's other various hardware to create your own custom supports. There's many predefined assemblies, steel cantilever configurations, cable tray supports, and HVAC supports. So let's just place a simple U-bolt at this point, and I'll show you how a couple components can get placed. So I'll pick the pipe, which will grab any sizes from the OpenPlant perspective, and I'll pick the steel that I want to attach it to, and a dialog appears. It'll automatically filter out what sizes from the catalogs. In this case, it's going to filter out all the 4-inch components or 4-inch U-bolts. So I would just choose whatever vendor U-bolt I want. So I'll just take the first one and choose OK, and it places that U-bolt. Next, let's look at some of the assemblies. So assemblies work a little different. You choose assemblies, and you can view down through a list of all the predefined assemblies. So I'll scroll down the list till I find the assembly that I want. And once I find the one I want, in this case, this clamp and spring assembly, I'll select the pipe, select the support, and it's going to prompt me for all the individual parts and pieces that go into making up that particular assembly. So in this case, we need to define the clamp size. We need to define the rod coupling size. So I'm browsing through the different sections here, picking all the size components I need. We'll define the hanger rod size and the spring hanger size. And once you get all these selected, you can save them to a template. So you don't have to, the users don't have to set those over and over again. You can save them to an assembly template. All those sizes will be predefined. So at this point, I'll just choose the pipe and the support or pipe and structure, and you'll see the assembly takes place there. Once the supports are placed, you can generate, you can pick all the components you want to be part of a drawing, and you can click this command to manually pick what parts and pieces you want to be part of the drawing. It'll show you all those parts and pieces, and it will automatically create this 2D drawing for you and start drawing it up for you with the bill of material on it and all the views that you've predefined, in this case, this particular support, an ISO view, and you can configure all that in the system as to what automatically gets placed on that drawing. And finally, the last step here is just, I'm going to show you how quickly you can generate a report. You can highlight your entire model and generate a report of all your supports in your particular model. And you can configure those reports through the administrator tool and make them look and feel how you wish with your company header on it and on any fields you want to report out on. So the last product we'll take a look at is OpenPlant Orthographics Manager. So OpenPlant Orthographics Manager can rapidly create some automated drawings, and it automates a lot of the stuff that may be kind of tedious to place, like automated dimensioning and labeling and reports, and you can pre-set up all of those. So what we'll see in this presentation is Orthographics Manager in action and some of the auto drawing generation of the orthos, the auto labeling and auto dimensioning. I'll turn on and off some different settings and show you the output. So not getting too much into the weeds here, there is some setup that you have to do to get some of the what we call a view area definition defined. So the first thing we do is define my view area definition, and we add in what models that we're going to create an ortho of. You set up what view you want to create, where that view gets placed on the border, all your section clipping planes. So there's a little bit of setup, and there's all these various configurations that you can toggle on and off what you want to see as far as labeling, inside labels, outside labels. And you can simply check those on and off, and those will either appear or disappear. You can get in all these other settings in here for key plan setups and nozzle reports and valve reports and revision labels and dimension and hidden line outputs and annotations. You can make piping go single line, for example, over or under a certain size. So there's a whole bunch of settings in here to predefine, and once all these are set up, you can go into your drawing generation and simply just generate the drawings. And what that does in the background there, it actually processes the drawing, and I'll show one here in a second when it's complete. So it automatically creates the extracted ortho from that particular view that you set up. It'll auto label, auto dimension, auto annotate nozzles, valve labels, anything else that you set up into there. So let's just make a quick change so you can see how quickly the annotation updates. So let's say I want to turn off the external dimensions, and I just want to include internal dimensions. So I'm going to check on include all. Say turn off the outside dimensions and just check on all internal dimensions, save it, and regenerate my drawing. You'll see I'll click over into the drawing, and you'll see that gets updated. And now all my external dimensions are turned off and the internal dimensions are on in there. So any of the settings you make, you can quickly toggle things on and off and regenerate to see what they actually look like. In this case, I'm going to turn them back on and actually show you how the drawing gets regenerated. And you'll see it populates the drawing, starts to do the annotation, and puts all my dimensions back on there again for external. So that's a little preview of OpenPlant. So what you actually saw today was OpenPlant PID, creation of intelligent PIDs, syncing back and forth from PlantSight. We saw OpenPlant Modeler. We saw some 3D modeling of piping and equipment and checking components in and out of PlantSight, generating bills of materials, generating isometrics, generating orthographics. We also saw a little bit of PlantSight. We saw the editing directly in PlantSight for the PID data, 2D and 3D visualization and version comparison. We saw OpenPlant support engineering and some of the various supports we placed and some auto drawing generation and support reporting. And then we finished off seeing Orthographics Manager, some of the auto drawing generation. So that's my quick rundown of the OpenPlant products. We'll open it up for questions. I don't know if you want to verbally unmute people, Chuck, or if we're just reading them, if there's any questions in the, I can't see that. I'll have to bring that up.
Yeah, there's no questions so far. If anybody has any questions, just go ahead and type them into the Q&A box. While we're waiting here, thanks a lot, Ed, for this webinar. It seems like pretty powerful software. So while we're waiting for the questions, everybody who attended today, hopefully will get a PDH credit. I know there's been problems in the past with Bentley trying to get those, and I still haven't seemed to receive the ones we had recently. So I'll still hand them in to Bentley and see if we can get PDH credits. Just to let you know too, we have webinars all set for like the next 4 or 5 webinars. In July, we're going to have one on Concept Station. After that, we got OpenSight, we got some OpenBridge, we got ProjectWise. So we got a lot of good stuff coming down the pike. So I'll probably send out the meeting invites probably 2 weeks before each. But the next one's going to be in July, and it's going to be on Concept Station. I don't see any questions, Ed, so I think you described it very well. We all understand it. If anybody does have any questions, you can go to glbug.com contacts, and you can pick my email and just send me some questions. And speaking of which, this video will be processed and uploaded to our GLBUG YouTube channel. I'll send a link out to everybody when that's ready to go. So, and I don't think we have any questions. I just want to say thanks for taking this time to put this webinar on for our group.
Okay, well, thank you, everybody. And there's my contact also. If you think of something after the fact about OpenPlant and you have questions about it, feel free to email me or Chuck, or, can get in touch with me, however you guys want to handle it. And we're here to answer anything you think of after the fact.
Sounds good. I think with that, we'll go ahead and end the webinar. So thanks again, Ed.
Thank you, everyone. Have a good day.
All right, see you.